Aguilar. I'm going to present, I'm from Klagenfurt University. I'm going to present our paper titled Dynamic Segment Repackaging at the Edge for HTTP Adaptive Stream. So first of all, I'm going to introduce the topic, then I will mention the contribution of our paper, then I will talk about the motivation to do this job, then the proposed approach, the proposed solution that we do for this problem. Then I'm going to mention the evaluation and discussion of this work, and then I conclude with conclusion on future work. So video streaming is a service that is increasing, is growing. This is not, right now it's the most widely used service in mobile network with 63% rate of usage in 2019, and is expected to grow in the upcoming years up to 76% by 2025 by Ericsson Mobility Report of 2019. And currently there are 4 media formats that all using this adapted media streaming logic. We have HLS, that is from Apple, we have MPEG-DASH, we have Microsoft Smooth Streaming, and we have HDS from Adobe. Now we have a common media application format, CMAF, that it is created with the purpose of using a common media format for all the video stream. Its using is increasing, it's becoming popular, but it's not yet supported by most devices. We can see here, this is the Bitmovin developer report of 2019, that they ask which video codecs are you currently using and which video codecs are you planning to implement within the next 12 months. The red one is planning to implement, and we can see that the popularity of CMAF is increasing. This is we use the data for the report of 2019, but because it was the last version available. But now the 2020 version is available, and CMAF, the planning to implement is up to 36%. So we can see that CMAF is becoming really popular and becoming more supported by more devices. The contribution of our work is first of all, the proposal to use CMAF as the common delivery format of segmented media in HTTP adaptive streaming, while supporting heterogeneous device. This is with different media formats. We present this in detail. Also, the operations that have to be performed for the on-the-fly media format conversion of the segmented media content are analyzed. And then we have a diverse evaluation of the benefit and cost of this approach. We include 3 different types. The first one is an analytical model and simulation to quantify the bandwidth savings in the core network or in the CDN. Then we measure the runtime overhead of the operation that we introduce with our approach for this media on-the-fly conversion. Finalize, we have a result of a real experiment in a video streaming testbed to see the impact in a real scenario. So the motivation of our work is that CMAF provides great benefits. We can see here, first we have a scenario with 4 media formats, the 4 main media format dimension, HLS, DASH, Smooth Streaming, and HDS from Adobe. And here we have the CMAF scenario. So we can see 3 main advantages of CMAF. First is the less storage. The architecture will be like, those are the user, this is the encoder, the video server, and this can be the CDN or the edge node that is close to the user. So we see 3 great benefits here. 3 is the less storage needed. Here in the server or in the edge, we can see that the storage is less, as we already store as CMAF. Also, bandwidth savings across the network. We have different media format, but actually can be the same video. we see that we are duplicating the data sent through the network. It's redundant. Also, we have more cache efficiency in the edge node because all users are targeting the same video. Because now, for example, this can be the same video, but it's in 4 different media formats. So the cache will be 4 different caches for the different media formats. But we have a problem right now. As I showed, the using of CMAF is increasing, but it's not yet supported by most of devices. So we want to leverage this advantage, but support all the devices. There come our proposed solution. Our approach is to use CMAF in the backhaul and perform a media format conversion, that's also called transmuxing, to the desired media format at the edge. This way, we maintain the advantage of CMAF while we support all the devices. For example, imagine this user is an HLS user, but it do request a video, but the video is sent on CMAF content, and it's also cached at CMAF at the edge. Then at the edge, we perform here the transmuxing to deliver HLS content. And also that cache can serve, that video can serve this user that is using Dash, because we perform here again the transmuxing operation to serve the same content to this user. For the evaluation and discussion, we did 3 different evaluation methods. The first one is an analytical model and simulation. We have a bandwidth savings up to 20%, comparing with different media format. We do study different distribution of the media format, 30% HLS, 40% DAS, and 30% the others, for example. Yeah, this analytical model and simulation are detailed and explained in the paper for those who are interested in the details of this analytical model. Also, we do processing time measurement for different operations, but for the transmuxing, for the media format conversion operation, is around 45 to 67 milliseconds. Also, we use the evaluation method of real experiment to evaluate the full repackaging time to take in a real scenario. So here, for the processing time measurement, we use FFmpeg and Bento4 tools. And in this table here, we have different segment duration in seconds. For example, this can be the 4 second duration, and different resolution. And we measure different operations. For example, the DAS segmentation, the HLS segmentation, and the transmuxing. Also, we have the same table with encoding and the encryption and decryption times in the paper. And we can observe here that is a clear correlation between segment size. Segment size can be higher because of the longer segment duration or higher quality, and the processing time of the operation. We see here how it's increasing, and also how across the different resolution, how it's increasing. Okay, now we measure every operation that takes place for do-over approach, right? So now we will compare the 2 different scenarios. The scenario with 4 media formats, all the operations that take place in those scenarios to deliver content, and the operation that we do in our approach, in the CMAF scenario when we deliver CMAF and do the transmuxing at the edge. So what operation we have in the classic scenario? This is simple. We have first the encoding of the video, and then for each media format, HLS, DAS, HDS, and smooth streaming, we do segmentation of the content and then encryption of each segment. On the other hand, in the CMAF scenario, in our approach, the computational time is we divide into the operation that takes place in the server and the operation that takes place in the edge, at the edge. For the server, it will be encoding, segmentation of CMAF, and then encryption of this CMAF segment. When at the edge, this CMAF segment arrives, we have to decrypt those CMAF segments and then perform the transmuxing to the desired media formats, and then again the encryption of this individual segment. So we compare the total time of these two approaches, and we get that when the edge node has 1.64 times more processing power per segment, this is important because, of course, the origin server has more computing and processing power, but also higher load. At the edge, we have to think that, okay, we have less resources, but also the load we serve not so many users as the origin server. So if the edge node has 1.64 times more processing power per segment than the origin server, the total time that takes to perform all these operations that we study is the same. And if it's higher, or approach will be faster. Here we saw in this table we can see different ratio of computing power per segment of server and computing power per segment of the edge. And we see, for example, that if the edge is 5 times more processing power per segment, our approach is twice faster. It's consumed half of the time. Okay, and the next evaluation method, and the last one, is to provide a better understanding of the performance of our proposal model in a real life settings. We conduct tests in a cloud infrastructure. And in this cloud infrastructure, we have 3 nodes: the origin server, the edge, and the client. And we perform a classic video stream operation. This is the client requests a segment to the server. It goes to the edge, but in the request, the edge just forward. And the server sends the segment back to the client. We compare 2 different clients. The first client is using DASH using CMAF. So when the segment is forward from the origin server to the client, in the edge, it won't be any transmuxing, as the DASH is using CMAF. So it's, let's say, transparent. I will be forward. But also we have a client here that is using HLS, and it's like a standard HLS. It doesn't use CMAF. So therefore, when the segment is forward to the client, at the edge it will be a media format conversion or transmuxing operation that we done. We test with Babak bunny video in full HD resolution with 4 second segment encoded with ABC, and we measure the end-to-end latency. So what we have in the graphic, we can see here in this axis, we see the end-to-end latency measured in milliseconds. Also, this is the different segment numbers. We watch the entire Babak bunny video, so this is the segment number. Here we have the segment size. The segment size of each segment is in this blue line. That because of the encoding, you can see that sometimes it's bigger, sometimes is shorter. And we see here the difference between the mean end-to-end latency of DASH using CMAF, that is this orange line, and the end-to-end latency of mean HLS. we have here a gap. We have here a difference. This difference is indeed is the transmuxing time, is the media format conversion time. And we measure this, and we see that the DAS using CMAF, the mean latency is 144 milliseconds, and for HLS is 280 milliseconds. So this difference of 136 milliseconds exists because of the media format conversion time. We can see here that this difference is bigger than what I showed in the previous evaluation method of measuring what I measured the operation times, right? This is bigger. Why? Because this is a real test bed. So the difference, this implies more operation, like writing in the buffer, the input and output operation, and also the transmuxing operation itself that is performed by FFmpeg. So in a real experiment, it will take a little bit more time. Finally, for the conclusion of this paper, we propose a model where we use CMAF to deliver media format segment from the origin server to the edge. And then we perform this media format conversion at the edge if it's needed. If the user doesn't support CMAF, this media format will be performed. This approach allows to get all the advantages of CMAF, like more bandwidth savings that we studied is up to 20%, more cache hits and fewer storage demand, while we are being able to serve heterogeneous devices like different media formats. The result of our analytical model shows that a bandwidth savings up to 20%. That is a good number for different real media format distribution. In the paper is shown that we study different distribution of the media formats. Also at the edge, if the edge has 1.64 times or more the computing power per segment that the origin server, it can be expected due to lower load, as I mentioned before. Okay, we have less resources, but also lower load. The proposed model exhibits the same or better performance in terms of computational time than the classic delivery scheme with all the media formats. Finally, our model can be used with future content formats by changing the format distribution and rerunning the time measurement. There is no restriction of CMAF per se. We can, if a new format comes, so we can study this media format with the same using this model. So thank you so much. And if you have some question, I will be happy to answer.
So thank you so much also to you for your presentation, for your nice presentation. And so we have almost 5 minutes for any question and answer from you and from the audience. So any questions?
Yeah, I would have a question. So you said, if I understood you correctly, so it's a kind of a transient technology, so up to the point where CMAF is fully used everywhere, right? So, and you said in 2019 the usage of CMAF was about 5%, and now in 2020 it already raised to 30%. So then if you just continue this growing, then in about 5 years, CMAF will be fully distributed on all devices. So then do you see still an application for your approach, or?
Okay, thank you for your question. Yes, the transition is, just to clarify, now this is currently the user that the developers that employs CMAF was 12% in 2019, and in the report of 2020 is that 21% of the users are currently using CMAF, and 36% is expected to implement during the next year. So yes, our solution is a transient solution. It's difficult to it's difficult to make the transition to the classic HLS and HLS, DAS, and classic media formats to the CMAF, because okay, I'm producing content, I don't want to do it in CMAF, or at least it's not my priority, because not every devices support CMAF. So it's like, okay, I will prioritize HLS and DAS because more people use HLS and more devices support HLS and DAS. That's for the producing, but also for the people that those people that implement CMAF in the devices. They say, okay, there is not so many content in CMAF, so I don't have a lot of motivation to make it. Okay, it's improved. It's an improvement, but let's say it's not my priority. I will, because also we can see here that there's a lot of people that still want to planning to implement DASH. So this transient solution can solve that problem. I think it's, yes, if everyone supports CMAF, you won't be needed to do this. But yes, I think it's important to make right now a transient solution to solve this problem. And also, as I say in the conclusion, this is not restricted to CMAF, but if this study can be done with different media distribution, if we have different, because in the future it's clear that that new media format will be coming. So this study can be also done with different with the upcoming media formats.
Okay, thank you.
Thank you.